Hello everybody, welcome to Mrs. Baker's Chemistry Corner. This is the Monster Paper 4 for Module 5 and this is question 8. Okay, so 25 centimeters cubed of a gaseous hydrocarbon, which has the formula CXHY, was burnt in 150 centimeters cubed of oxygen. It's telling us we've got an excess of oxygen, so we've got more oxygen than we can use. After cooling, the volume of gases remaining was 100 centimeters cubed overall. This consisted of 75 centimeters cubed of carbon dioxide, 25 centimeters cubed of unreacted oxide. The water that was produced in the reaction was a liquid. So all volumes were measured at the same temperature and pressure. What is meant by an excess of oxygen? Well, if we have an excess of anything, we have more moles than we can possibly react. So we have more moles than we can use fully. So for the next question, what was the volume of oxygen that reacted with the hydrocarbon? Well, we've highlighted that we started off with 150 centimeters cubed, and it's telling us that we ended up with 25 left over. So if we do 150 minus 25, that will give us 125 cm cubed. So we used 125 cm cubed. Complete the table to show the smallest whole number ratio of the volumes. Well, for this, what we need to do is work out how much gas we used in the whole thing. So it's telling us we had 25 centimeters cubed of the hydrocarbon. We know that we had 125 centimeters cubed of the oxygen that we used, and it told us that we had 75 centimeters cubed of carbon dioxide produced. So now what we need to do is work out the ratios. So if we say that this is 1, if 25 is worth 1, then 25 times 5 is 125. So this will be a ratio of 5. We've got 5 times more oxygen than we have got the hydrocarbon. And for the carbon dioxide, we've got 25 times 3 gives you 75. So the ratio is 1 to 5 to 3. Now what we need to do is use our answer to be 3, which is the ratio, to balance the chemical equation. So we've got 1 of the hydrocarbon, we don't need anything there. We've got 5 of the oxygen. We've got 3 of the carbon dioxide. Now we can work out how much water we had, because if we've got 5 oxygens on this side, then that's actually 10 oxygen molecules. And remember, everything on the left has to balance out with everything on the right. So we've got 10 oxygen molecules over here. We've got 3 times 2 over here. So we've got 6 already. So we need another 4 oxygens over here. To make another 4 oxygens, we need a big 4 here. Now we can work out the formula of the hydrocarbon. So if we've got 4 times 2 hydrogens here, then we've got 8 hydrogens, which means we must have C8. No, we must have H8, sorry. And over here we've got 3 carbons because we've got 3 times 1, so it must be C3H8. Hope that was helpful.